More than 10 years have passed since Israel seriously started worrying about the decline in fresh water supplies in the country. A lot has changed, and now it desalinates about 75% of its drinking water from the Mediterranean Sea and is also a world leader in reusing wastewater. Nearly 90% of it's used for agricultural irrigation and other similar purposes. It seems amazing to the whole world, but Israel really managed to get out of the water crisis in no time. Today, this country is considered a global leader in drinking water production, and it's truly impressive. Seriously, going from a water shortage to abundance in just about 15 years seems like no one else has ever done that. While the U.S. is struggling with the drying up of the Colorado River and Germany's facing a threat to the Rhine River, Israel's celebrating its abundance of water sources, teaching other countries how to tackle the climate crisis, and even increasing the water quota for a neighboring country. But that's now. In reality, the issues of access to fresh water is characteristic of almost the entire world. Throughout the 20th century, global water use grew more than twice as fast as the population. That means there weren't that many more people, but they were using a lot more water. You can't really talk about Israel without mentioning that most of its land is classified as arid or semi-arid. Rainfall only occurs in the winter, mainly from November to March. The average annual rainfall ranges from 16 to 32 inches in the northern and western parts of the country, and it gets even less as you move south and east. The dry season, when there's almost no rain, lasts from early April to the end of October. Half a year. Water shortages have always been a serious problem in Israel. The vast agricultural lands are in the south of the country, while the main water reserves, on the other hand, are in the north, where there's less farmland. In short, in such conditions, a water crisis was simply unavoidable. It became one of the reasons for a huge number of conflicts in the region, including military ones. And this crisis was actually the reason Israel started the project to pump water from the sea into the lake. But first, coffee. Just an unobtrusive reminder to do something under the video. And thank you for you-know-what. After the creation of the State of Israel in 1948, it became obvious that the country was in desperate need of fresh water. The solution was simple: move water from the north, where it existed, to the south, where it was most needed. This is how the National Water Carrier of Israel was created, with the main goal of transferring water from the Lake Tiberias to the densely populated center and dry south, as well as regulating water supply across the country. It's about 80 miles long, and each hour up to 19 million gallons of water can flow through it, which adds up to a total of 450 million gallons per day. Naturally, this isn't just one pipe or even two. The water supply system consists of a whole network of giant pipes, open channels, tunnels, reservoirs, and large-scale pumping stations. Building all of this was a very complicated technical task, as the water supply passes through different terrains and elevations. But we'll get back to the construction process a bit later. Just keep this in mind for now. Water flows into the National Water Carrier of Israel through a pipe submerged in the northern part of Lake Tiberias. The water then travels to the Sapir pumping station, which pumps water from 700 feet below sea level to 843 feet up to an elevation of 144 feet above sea level. After the water reaches the 10.5-mile-long Jordan Canal, it flows into the Nahal Zalman Valley Canal. This canal is actually an active reservoir with a capacity of about 264 million gallons. The Zalman pump station pushes the water another 380 feet up into the Yaakov Tunnel, and then it continues on to the Beit Netofa Valley Canal. This one's another 10.5 miles long. That's how the water gets to the Eshkol reservoirs. There, it's cleaned of sediment, chlorinated, and tested. If everything checks out, it goes into a 53-mile pipeline all the way to the city of Rosh Hashanah, where it enters the Yarkon Negev water supply. Here, a side branch of the main line of the National Water Carrier of Israel branches off. It supplies water to Jerusalem. Israel's internal water needs currently amount to about 528 billion gallons per year for domestic, agricultural, and industrial use. At the same time, the two main technological breakthroughs, desalination and wastewater treatment, make up about 264 billion gallons. You get it, right? There's a shortage. Only through new technologies has Israel been able to double the amount of water available to it over the past 20 years. Actually, the idea of using northern waters to make the South bloom came up even before the founding of the State of Israel. Walter Clay Loudermilk, a well-known soil conservation expert, published a book called The Land of Israel, The Promised Land in 1944, where he proposed this idea. The book, in turn, encouraged the leaders of the Jewish Agency to ask American engineer James Hayes to develop a plan that would use the Yarmouk, Jordan, and Litani rivers for the benefit of the Negev region. That's where the desert of the same name is, so water was definitely needed. In 1951, Ben-Gurion, the head of the Jewish Agency and later the Prime Minister of Israel, decided to start laying down a pipeline. This was needed to achieve two goals: to create a modern society based on cutting-edge technology and to spread the population across the country, including the Negev. The construction of the water carrier system started in 1953 and was completed in 1964. The cost of the project was 420 million Israeli lira. Back then, Israel had this currency. The carrier was a huge project for a poor country. It's believed that more than 4,000 workers were involved in its construction, but there's info suggesting that at the peak of construction, 1 out of every 14 able-bodied citizens was working on digging, welding, assembling pipes, or other tasks for the new water supply system. It cost Israel about 5% of its national GDP. An unbelievably huge amount. Not to mention that new engineering technologies had to be invented. After the system was set up, 80% of the water went to agriculture and only 20% was used for drinking. But over time, the situation changed, and by the early 1990s, the National Water Carrier of Israel was supplying half of Israel's drinking water. The 80-mile-long pipeline is rightfully called the Israeli engineering marvel. It makes it possible to build new cities in places where the geographical conditions made it more difficult or even impossible to do so. The National Water Carrier of Israel managed to move the inhabited southern border of the country from the south of Rehovot to the current southern edge of Beersheba. A national agricultural economy was created with billions of dollars in exports. Importantly, the pipeline turned Israel's water supply from a collection of local or regional sources into a national system. This is a crucial element for the integrity of the state. Lake Tiberias became the starting point of the National Water Carrier of Israel, but it wasn't just about moving the water, but also about desalination, reducing the salt levels to make the water drinkable. Israel has a lot of experience with desalination. For more than 2 decades now, it's been taking seawater from the Mediterranean and treating it through a process called reverse osmosis. While other places like California rely on it during dry spells, desalination is just part of daily life in Israel. Israel currently runs 5 big desalination plants along the Mediterranean coast. These plants produce about 160 billion gallons of water every year, most of which goes for household use. Desalination meets roughly 80% of the demand in this sector. At the moment, 2 more desalination plants are under construction through Israeli government tenders. The idea is to increase the supply of desalinated seawater for everyday needs, which should take care of 95% of the demand. It's set to happen quite soon, by late 2026. You could say that ever since the first desalination plant started working in 2005, Israel has needed less and less water from Lake Tiberias. Nowadays, hardly any water is taken from it, and it seems that's for the better. Just to be clear, the water in Lake Tiberias isn't salty, at least it wasn't. With erratic rainfall, hotter weather, and intense water pumping, you could say the lake's been pushed to its limit. And yet, for decades, it was Israel's main source of fresh water. The years from 2013 to 2018 were especially dry, rainfall was below average, and the water level in the lake dropped to the black line, which is 705 feet below sea level. That was the point when water pumping for the country's needs was supposed to stop. Here's a photo taken back in 2018. It shows the tourism director of Ein Gev Resort pointing out the water level to journalists. And words are, in fact, unnecessary. The lake shrinking is partly caused by climate change. It's getting hotter all over the planet, which means droughts are happening more often. They're also getting harsher and lasting longer than ever before. On average, Israel now gets 30% fewer rainfalls than in previous decades. This chart shows that droughts, marked in red of course, in Lake Tiberias Basin have become more frequent and intense in recent years. In 2018, the drought caused a shortage of 660 billion gallons of water in the country compared to typical years without drought. That's equal to 1 million Olympic-sized swimming pools. Urgent action was needed to prepare Israel for global warming combined with the rapid population growth. Some models already show that in the second half of the 21st century, rainfall will decrease by 10 to 15%. In other words, the problem of the lake shrinking will only get worse. But Israel has an idea of how to fix it. It's simple. If there's not enough water up north, it needs to be carried there. Right. So basically do the complete opposite of what the national water carrier of Israel was designed for. Mekarot, Israel's national water company, and the Water Authority have launched the largest project of its kind in the country's water infrastructure, which includes a new pipeline. This time, it'll pump desalinated seawater from the Mediterranean Sea into Lake Tiberias. It seems to be one of the biggest infrastructure projects in recent years, with a cost of at least $280 million. Mekarot believes that this massive project will solve several problems at once. First of all, it's of course the ability to maintain the water level in the lake, which Israel actively uses and which still serves as a year-round water source for various sectors of the economy, including agriculture. The infrastructure is designed for this. The second issue is geopolitical. Even in dry years, Israel supplies water from Lake Tiberias to the Kingdom of Jordan because it's specified in the peace agreement the two countries signed. Recently, water deliveries to Jordan were doubled to 26 billion gallons per year. This means there should be enough water in the lake to meet these needs as well. What about the technical side? The optimal amount of carried freshwater has been recognized as a maximum of 31 billion gallons per year. From the sea to the north, another important point is how the water supply system will operate. It won't be pumping water all the time automatically, but only under control and with consideration of Israel's economic needs. What Israel is doing is unprecedented. No one has ever taken salty seawater, desalinated it, and then poured it into a freshwater lake to be pumped into the general water supply system. It's incredibly complex and expensive. What's it all going to look like? So according to the plan, it'll be a 5.2-foot wide water pipeline stretched over 19.3 miles. These pipes will pump water from desalination plants in the south of the country back to the north. Eventually, the plants will work at a capacity that will allow the company, Mekarot, to raise the water level in Lake Tiberias by about 1.6 feet. This innovative project could become a new model for regions around the world hit by drought, if it works, of course. It's too early to talk about results. The project was officially launched only in 2022. It's already clear that the plan to pump desalinated water into Lake Tiberias will allow Israel to treat the freshwater lake as a sort of savings account for particularly dry years. Storing excess desalinated water there is cheaper than anywhere else. After all, it's a natural water body that's been around for tens of thousands of years and does its job well. In the height of summer, when Israel uses the most water, Mekarot will be able to draw water from the lake without worrying about hitting the black line. This might spare the country from having to build extra desalination plants that are really only needed during peak demand and would sit idle the rest of the time. Plus, the country's already run into trouble finding spots for new desalination plants. Locals were furious about losing access to the beach. In winter, desalination plants make more water than the country needs. They used to just shut them down temporarily, but now that extra water will go straight into the lake. What about the quality of this water? I mean, Lake Tiberias is a natural body of water. Wouldn't desalinated water be bad for it? The truth is, nobody really knows because nothing like this has ever been done before. What we do know is that even without the salt, seawater is different from lake water in other ways, so it can't not affect the ecosystem. Basically, Israel's planning to pump water into the lake that couldn't naturally exist there, and that's raising some concerns. But so far, tests show that this new water seems unlikely to have a big impact on the existing species. In fact, it might even help the lake cope with climate change by speeding up water circulation. This, in turn, would stop bacteria from growing too fast and might help bring down the water temperature. But the thing is, the drying up of Lake Tiberias isn't the only environmental issue Israel's had to deal with in recent years. The Dead Sea's also slowly disappearing. This is En-Gedi, the place that used to be a resort. Families would come here to float in the extremely salty lake, but now it's just dangerous. The first sinkhole appeared here back in the late 80s, and since then more and more of them keep showing up. Over the past 4 decades, more than 6,000 sinkholes have formed along the Israeli side of the Dead Sea, making large parts of the shoreline too dangerous to visit. And the reason's simple. The Dead Sea is drying up. The water level in it has been dropping by over 3 feet a year, and its surface area has shrunk by about a third since the 1960s. It's a stark example of what people can do to nature without even realizing it. The thing is, the Dead Sea's water level is largely maintained by the flow from Lake Tiberias and the Jordan River up north, but in recent decades, that flow is slowed to a trickle. Agriculture and mineral extraction take out more water than nature can replenish. How does it all work? As the water level in the Dead Sea keeps dropping, patches of land that used to be underwater get exposed. As the salty water recedes, it leaves behind a thick layer of salt about 65 feet below the surface. Then, when fresh water from winter floods flow down the mountains, it seeps into the ground, dissolving the salt layer and creating an underground void. And after some time, a sinkhole forms in that spot. You know why there's less water in the Dead Sea now? It's not just global warming, it's also the Jordan River that feeds the Dead Sea. The river flows through the Lake Tiberias. That's the very same lake, now shrinking, where people have pumped out way too much water. As a result, the Dead Sea gets way less moisture. And of course, climate change and other natural processes are just making things worse. The biggest news from the past few days is that I've come up with something. Infrequent irrigation. By now, you've probably realized that Israel is a pro at mastering, conserving, and making the most of water. And the Tomgrow startup is yet another proof of that. The company lets farmers and plant lovers almost forget about watering, giving them more time for things that really matter. The innovation is all about cutting down plant watering to just twice a year with zero harm to crops. The technology, called Medium X, consists of clear gel cubes that replace soil. Over the past 3 years, professors and doctors from Tel Aviv University have worked on this project, and it seems like they've come up with something truly groundbreaking. The gel cubes are based on a unique 3-dimensional nanostructure that holds moisture effectively, creating the perfect conditions for plants to grow and thrive without constant human care. To be more precise, this special material is 99% water mixed with essential nutrients, ensuring steady plant development without the risk of overwatering or nutrient depletion. Plus, this technology cuts water usage by 75% compared to traditional methods that require watering every week. The people behind the startup say their invention could address environmental challenges in farming. They're literally urging us all to pitch in and fight water supply problems by purchasing some of these gel cubes. Not sure about you, but to me, it sounds like a pretty good idea. Maybe this way I'll manage to keep at least one plant alive. Water out of air. What are some other ways to conserve water? For instance, by extracting it straight from the air. Several universities in Israel are working on projects like this and even putting them into action on their campuses. For example, one of them has a unique station set up on its roof that turns humidity from urban air into water powered by solar panels. And it's not just a prototype. Anyone can try this eco-friendly water by using a specially installed faucet. But wait, can you really get pure water from the air? I mean, with exhaust fumes, dust, and all that? Turns out you can. According to recent reports, the air in crowded cities like Tel Aviv can actually be clean enough to meet strict drinking water standards. What's more, water produced from air meets not only Israel's requirements, but also WHO standards. In short, it's a great initiative in times of constant water shortages. Drip irrigation. Israel seems to be doing literally everything to save water and set an example for the whole world. Another cool solution is the drip irrigation technology, invented in 1959. Yes, it was a long time ago, but even today this method's still relevant. What is this drip irrigation? It's an advanced method of growing plants that ensures high water use efficiency. In drip irrigation, the necessary amount of water and nutrients is delivered right to the roots at precise times, supporting the optimal growth of crops. In short, this watering method saves water and energy, significantly boosting yields. Any other benefits? First, fertilizers applied through the system are distributed more evenly, reducing the risk of contamination of underground water in rivers. Second, this method adapts well to any soil type and doesn't require high pressure, which makes it suitable for various conditions. Third, drip irrigation also helps reduce the risks associated with droughts and climate change. When it comes to water efficiency, drip irrigation significantly outperforms other methods like sprinkling. And this is really important because Israel is literally filled with deserts and semi-deserts. Don't forget about the frequent droughts, the desertification of farmland, rapid urbanization, and resource depletion. None of this is helping, and drip irrigation is literally saving the country. Israel is eager to share its expertise with other countries. For example, a delegation from Utah, which also has a dry climate, visited the Negev Desert to learn about agriculture in one of the harshest regions on the planet. Israeli experts showed their lush greenhouses where tomatoes and eggplants were grown in vertical gardens, and all these crops were watered using drip irrigation. The American delegation, for its part, noted that the plants indeed got very little water, but despite that, the strawberries they tried on the farm were really tasty. All in all, Israel really did a great job. AI is stealing water. If you ask ChatGPT how much water it uses, it'll reply that it doesn't have a physical body and doesn't drink water. But when it comes to computing power and how servers work, water's definitely required. The environmental impact of an online conversation depends on many factors, including how long the chat lasts, the number of people involved, and the tech we're using. And while AI's water consumption isn't anywhere near what's used in agriculture or industry, it still adds up, and it's a pretty significant amount. So one session of communication, which includes up to 50 prompts, leads to water usage equivalent to 0.1 gallon. Not much. But if you multiply this by the daily audience of this service, which reaches 13 million users, the numbers become staggering. From 170,000 to 1.7 million gallons of water per day. To give you an idea of how much that is, this amount of water is enough to provide for 4,300 to 43,000 people in developed countries. In short, AI is really stealing water from humanity, and that's pretty sad. But even worse is that these online services are also emitting carbon dioxide. According to studies, the carbon footprint left by one message in ChatGPT is much bigger than that of a simple Google search, resulting in about 0.03 ounces of CO2 emissions. Yeah, it seems like a tiny amount, but listen on. Overall, using AI requires about 77,000 kilowatt hours of energy every day, based on emission data from Israel, where each kilowatt hour consumed results in 1.37 pounds of CO2. The daily emissions reach, get this, 47.7 tons. That's roughly the total carbon output of about 2,000 citizens of the country in a single day. Good thing I'm doing all the video scripts on my own. Looks like I'm saving the planet. You owe me a like. See you later.